In this video, we'll be looking at this application problem revolving around parabolas. This actually more is a paraboloid than it is a parabola. A parabola is a two-dimensional object. A paraboloid is a three-dimensional object. So a satellite dish has the shape of a paraboloid. The signals that it receives are reflected to a receiver that is located at the focus of that paraboloid. If the dish is 8 feet across at its opening and 1.25 feet deep at its center, determine the location of its focus. Now, in reality, we would see these satellite dishes in some way angled, so they'd look something like this. There'd be a receiver here. It's this round rectangular object, and then it's got the metal poles that hold it in place. And then again, you've got this giant dish. So this is what it would look like if I were an artist, to some extent to the normal eye. Now, I'm not going to use this paraboloid to determine what my location of my focus is. Now, to better understand how this actually works, it's important to think about all these radio signals that come in and bounce away from it. The way it works is the radio signal comes in, hits the paraboloid edge, and I should probably draw it into about there, where it hits the paraboloid edge, and then it bounces perfectly back into the signal receiver. And again, this is why these things are built in a parabolic nature, is because of the way that it's built. Anywhere that it hits this dish, or at least anywhere it's supposed to hit this dish, that receiver is supposed to be in a perfect position for all of those signals, wherever they're being sent from, to bounce perfectly back into that receiver right there. That's why there's that giant ball-like object at the edge of it. It's more probably cone or cylindrical shaped object. But in any case, this is what the idea of this satellite dish does, and that's why it has to be paraboloid in nature. But for me to better understand where that focus is going to be that location of the receiver, I need to go ahead and draw this in a way that makes sense to me. So what I'm going to do is I'm going to go ahead and draw an XY coordinate plane. That's the first thing I'm going to do. The second thing I'm going to do is I'm going to go ahead and draw my vertex sitting on the origin, because a vertex sitting at the origin generally makes things a lot smoother. So the last thing I need to do is I'm going to go ahead and draw this paraboloid. And now I'm going to draw the paraboloid without the three-dimensional object. So really I'm just going to draw a parabola. Now when I draw this parabola, again, it's not drawn to scale. The length across the top has to be 8 feet. So I'm going to go ahead from here all the way over to here. I'm going to cut the rest of the paraboloid off. That distance right there is supposed to be 8 feet across. So this point over here, just to clarify, that point would be 4, comma, something else, because it's 8 feet across, and the depth at its center is 1.25 feet. So this depth from here to here is 1.25. So that point is really 4, comma, 1.25. The reason why it's not 8 is because the distance from here to here, from the distance from here to here, in total has to be 8. So just this half distance, as I'm correlating this on a coordinate plane, it has to be over 4, up 1.25. And that's the same thing for this point over here. So now I got to figure out where this receiver is. Is it going to be here? Is it going to be way out here? Is it going to be here? Where does this receiver actually sit? So I'm not going to draw it in place. What I do know is that if I can identify the vertex, well, that's 0, 0. My focus is supposed to be 0 in this case because it's my x squared section, and my y is the thing. I'm supposed to have 0, comma, 0 plus p. So if I can figure out the formula for this equation, the formula for this paraboloid, that means that I can then find out what p is and simply plug it in, finding the focus and therefore where the receiver should be sitting. So with this being stated, again, and all this drawn, all I really have to do is find out what p is, plug into that formula, and we're good to roll. Let's go ahead and see if I can identify this equation. First off, I know that my x squared has to be the squared term. I also know that my h and k are both 0 because of where I put the vertex. So this is x squared equals to 4 times p times y. How do we find p? Well, since I've identified that point, the only thing that I haven't used in this equation yet to determine what p is, I might as well try and use that point to find p. Well, I know that's an x, and I know that's a y, and I know that this point is actually on the parabola. So in this case, I can just go ahead and plug in 4 for x. I can plug in 1.25 for y, and therefore I can go ahead and solve for p. In this case, I'm going to do math a little bit lazily. I'm going to divide by 4 on both sides, so this becomes 4 equals to p times 1.25, and then I'm going to divide by 1.25 on both sides. When I do that, 4 divided by 1.25 is going to be approximately 3.2. So p is approximately equal to 3.2 when I've done this division, and therefore I know that approximately 3.2 feet above the vertex my focus should be sitting. So my focus should actually be sitting at approximately that point. So if I wanted to draw it in here, this is 4 feet high. The focus should actually sit somewhere about there. That's where my receiver should actually be sitting. And again, with the picture drawn and this point identified and labeled as being the focus, it should be obvious then where the focus sits, or where the receiver sits in relationship to this parabola that I've drawn. If we need to be more specific and actually have a sentence identified, we should say that the focus or the receiver should be 3.2 feet above the center of the paraboloid. Again, it should be 3.2 feet above the center of the paraboloid. The reason why we're using feet is because the original problem was given all in terms of feet, 1.2 feet, as well as 8 feet in terms of the information. So that's how, again, satellites more or less work, and in addition, where the receiver is supposed to sit in relationship to the rest of the satellite.